Good morning. Welcome to the class on surface mining technology. Yesterday, we have discussed something about surface mining technology. We have given the introduction to the subject. What are the objectives and some layouts, choice of mining methods, and the processing methods. Also, we have discussed about what is surface mining. Sorry, something is not going, just wait. Just wait, something went wrong. Yes, now it is okay. So, in the previous class, we have discussed about the surface mining technology. Sorry. Yes, now it's okay. So, the about this topic we have discussed what are the objectives and the layout of the anatomy of a mine, choice of mining method, and choice of mineral processing methods. What is a surface mine? What is the history of surface mining? And the surface mining operations were discussed in the previous class. The surface mining, these are the some of the pictures of surface mining methods. These things we have discussed yesterday. And steps of surface mining operation also we have discussed, like your mechanical excavation methods, aqueous methods. And the subdivision of surface mining methods are also discussed in this table: mechanical excavation methods, aqueous mining methods. So in the mechanical excavation method, open pit mining, open cut mining, open cast mining, terrace mining, strip mining or flat terrain mining, contour strip or hilly terrain mining, auger mining, glory hole mining, quarrying. Similarly, if you are working with water, that is called your aqueous method. And the aqueous method is used for placer deposits by panning, sluicing, dredging, and hydraulicking. And also solution mining is there, which is carried out by heap leaching and in situ leaching. So we have seen the mechanical excavation methods. This is the figure refers to classification of surface mining methods. And yesterday we have discussed about the open pit mining method. So the this is the ore body. This pink color is the ore body, and this ore body is covered by the waste materials. So you have to remove this waste materials, which is called your overburden, and it is dumped in the dump yard, mining dump yard. And the pink color ore body is taken to the mineral processing plant for metal production. Okay, so this is the layout of an open cast, open pit mining method. So here mine working open to the surface, that is why it is called here open pit mining method. It is a funnel shaped hole in the ground with a ramp spiraling down along sides, allows moderately deep ore to be reached. Operation is designed to extract the minerals that lie very close to the surface for the shallow deposits. It is used when the ore body is near to the surface and there is little overburden waste rock which is to be removed before getting the minerals. This method is usually employed to exploit the near surface deposits, shallow deposits, shallow deposits, or the one that has a low stripping ratio. We'll discuss about the stripping ratio afterwards. The waste material, which is the overburden, is first removed. Then the ore is broken down and loaded by the loading machines and transported by the dumpers. So transported by the dumpers. Okay. Generally, the low grade shallow ore bodies are mined by open pit mining method. It is a non-selective mining method. All high and low grade zones are mined. The mining rate is 20,000 tons mined per day. It often necessitates a large capital investment because you have to procure heavy earth moving machineries to to operate the mining operations. Therefore, you need large capital investment, but generally it results in high productivity, low operating cost, and good safety condition. So these are the advantages of your surface mining methods. That is why throughout the world, the surface mining method is adopted because it necessitates a large because uh, um, uh, uh, it is high productivity. You get more production at a low operating cost and good safety conditions. That is why this method is widely used. There are some design issues. How to design the open pit mining methods. Stripping the overburden is the first operation. First, you have to strip the overburden, remove the overburden to reach the mineral deposit. Second is the location of the hull roads. Location of the hull roads on which the trucks have to move while they carry the minerals from the mine to the processing plant. The equipments which are used for drilling, for blasting, for loading, and for transportation are of different sizes. Size of the trucks selected for the transportation of the minerals, and you have to do the fleet management. How many trucks will be needed, how many dumpers will be needed to transport the material from the mine to the processing plant. And the other aspect which is to be designed for the surface mining methods is the pit slope angle and the stability of the pit slopes. So these things will be discussed in greater detail whenever these chapters will come across. So this is the one open pit mine used when ore bodies lie very near to the surface. It is a large hole which exposes the ore body. Waste rock or the overburden is first removed. This is the second cheapest method, but has the largest environmental impact. I have told yesterday that the only drawbacks of open pit mining, is the environmental impact because a lot of trees are to be cut and the people who are living near the mine are to vacate the area. Their cultivation land will be affected. So there is a lot of environmental impact because of the noise, because of the vibration, because of the dust problem, because of the water pollution. So the environmental impact will be there. And because of the blasting, the uh, ecology of the area will be affected because the wild animals and birds, they cannot live in that area. They have to go away from that area because of the blasting in the mines. So this is the mine layout, open pit mining picture showing this is a typical open pit mine. Typical open pit mine. Uh, this is the outside dump area where the waste material is dumped. This is the typical non-hull road bench. This is the typical
Hello,
non.
sir. Sir,
Hello.
your slides are not visible.
Slides are not visible.
Yes,
No,
sir.
sir, it's visible.
Visible.
It's visible,
Yes,
sir.
sir, it's
Maybe
visible.
maybe in your network there may be some issue. Okay.
Okay, sir.
So here this is the typical non-hull road bench, and this is the typical bench wall. and this is a catch bench. These things will be discussed in greater detail afterwards. Typical hull road through which the trucks are moving from the mine to the outer surface, and this is the drill machine, a drill rig drilling out a new pattern of holes, because first you have to drill the holes, and after that it will be blasted, and after that it will be loaded, and after that it will be transported. So four unit operations you have to carry out in surface mining projects. One is drilling, second one is blasting, third one is loading, fourth one is transportation. So this is the loaded hull truck. This is the loaded hull truck going to run up mine stockpile. And this is the empty hull truck returning to the shovel. And this is the shovel loading the hull trucks. And this is the drilled out pattern, drilled out pattern about to be charged with explosives. So this is another view of an open cast mine. Open pit mining. Open pit mining is a funnel shaped hole in the ground with a ramp spiraling down alongside, allows moderately deep ore to be reached. This is the initial mining carried out in New Jersey, USA. This is another mine, copper mine in Chile. These are the benches, and these are the access ramps, and this is the dust generated in the mines, and there is a slope failure here, failure of the slope. So this is one example of open pit mine. This is clearly visible how the open pit mine looks. So at the bottom of the open pit mining, there is water accumulation because of the uh, strata water, and because of the rainwater, the water is accumulated at the bottom of the pit, and these are the haul roads through which the truck has to move and take the minerals from the bottom of the pit to the mineral beneficiation plant. Okay, this is one layout of an open pit mine, and these are the operations carried out to remove the overburden. This is the overburden material you have to remove to get the minerals. So this is the shovel, this is the dumper operated in the mines to remove the overburden. Here also, these are the drill machines, these are the dumpers, and the shovel is loading to the dumpers, and these are the drill machines. This is the way the open pit mining is carried out, and this figure some photos and machinery is used in open pit mining. So this is the loading, this is the a drag line, this is the drag line, and this is the shovel. Shovel is loading to a truck. Shovel is loading the material to a dumper, and the mining trucks are called your dumpers. Mining trucks are called your dumpers. You see the size of the dumper. You see the size of the dumper. They are very, very big. That is why they are called heavy earth moving machineries. This is the photograph. This is the photograph of a 360 ton, 327 metric ton haul truck. This unit is powered by 2750 horsepower engine, and it weighs 443,000 pounds or 177 tons. Empty truck. And this is the crossing in pit crossing unit. After the material is mined, it is crossed here in the pit itself. So this is the in pit crossing plant, and this is the drill machine drilling in the pit. And while doing the open pit mining, sometimes the trucks, the dumpers, they uh, overturn and meet accidents. So here is a boulder falling over the machine, and here is the truck moving on the road, and here the shovel is loading to the dumpers, and these are the dumpers which are moving, some empty dump trucks and some loaded trucks. So yesterday we have seen what is a bench height of the bench. This is the layout of an open pit mine. So this is the top bench, this is the middle bench, this is the bottom bench. So these are called your benches. And in the middle bench, access haul roads are there through which the truck has to move. Open pit mining method. So what is bench height? The bench height is the vertical distance between each horizontal level of the pit. The element of a bench are, unless geological conditions dictate otherwise, all benches should have the same height. The height will depend on the physical characteristics of the deposit, the degree of selectivity required in separating the ore and waste with the loading equipment, the rate of production, the size and type of equipment used in open pit mining is to meet the production requirements, how much mineral you want to produce, and what is the climatic condition of that area. Depending on that, the bench height is selected. So this is the uh, diagram showing typical open pit bench terminology which is used in open cast mines. So this is the pit floor. This is the floor of the pit, and this is the bench. This is the bench, and these are the benches. This is the bench, and this is the soil or overburden. Original surface having soil and overburden. Okay, so uh, uh, this is the bottom of the pit, this is the top of the pit. So the pit floor, bottom of the pit, this is the toe. This point is called your toe of the bench, and top one is called the crest of the bench. So if you join the toe of the bottom bench to the crest of the top bench, then you'll get the pit angle. This is the pit angle. Okay, so which is called your overall slope angle, overall pit slope angle. Okay, and this arrow, pink arrow, is the bench height. This is the bench height from from vertical height. This is the vertical height of the bench. Okay, and this is the slope angle of the bench. The slope angle of the bench, angle of slope of the bench, and this is the road and ramp width. This is the road on which the trucks has to move on. So this is the road width, and this is the uh, uh, beam width, beam slope angle. Okay, and this is the bench interval. This is the bench interval. So this is the crest of the bench. This one is the crest of the bench, and the top of the bench. This is the top of the bench, and these are the jointings, geological jointings, bedding planes, and this is the footwall structure. Okay, active outline is shown on the uh, uh, this is solid lines, and final outline is shown here. This is the final outline uh, uh, is shown by this green color. Okay, so the pit is having a floor, the pit is having an angle of slope and overall pit slope angle. Bench, weight of the bench, width of the bench, angle of slope of the bench, crest of the bench, top of the bench, and beam. In the case of a beam slope angle, there is a weight of the beam, width of the beam, slope angle of the beam, and interval, beam interval. So these are the characteristics of an open pit mine. So here we have to discuss how the open pit mining operations are carried out. Sequence of open pit mining operations for pipe like ore body. Open pit mining sequence for pipe like ore body. So this is the ore body, pipe like ore body. This one is the ore body. This side is west. This side is also west. This is the ground line. This is the ground surface. So you are going to mine this ore body. A section A, capital A is showing this section through ore body before open pit operations started. Then first you have to remove this overburden to reach the ore body, firmer surface. Then by forming the benches, you reach to the ore body, and left side waste material is there, right side is also waste material is there. This is the middle one is the ore body. So this section B through ore body just as ore is exposed. So after removing this surface overburden material, you have reached to the ore deposit. Then here you have attacked the ore body in C section through ore body as ore production commences. Ore is produced. Then further you go down and get more ore. So section D through ore body as waste stripping and ore production proceed. So you are removing the waste on both sides to get the minerals. Then section E through ore body as mining continues. So you go like this till you get more mineral, and section F through ore body as economic limit of pit operations is reached. So you go on mining till this point and get the minerals, and after this you cannot go further because the open pit has reached to its final uh, uh, pit limit. It has gone up to this depth. Beyond that depth you cannot go because the trucks cannot take the materials from the bottom of the pit to the surface. So that is why this is called the quarryable limit. This is called the quarryable limit, economic limit of open pit mining. So if you go further, you will handle more amount of overburden and it will not be economical. So that is why this is called the quarryable limit, or the quarryable limit, or the economic pit limit. So beyond this, you cannot go down. So that's why you have to go to underground mining. If the ore is lying at a greater depth, you have to go for underground mining. Surface mining will not be applicable beyond this depth. So this depth is called your economic pit limit. This is the depth, this is the extension area.
Sir,
Hmm.
sir,
So
it will be changed if the economic value of that mineral is
yes,
or
yes,
coal is
great.
that
Yes,
change.
yes. If the grade of the mineral is uh, uh, high, then you can go because it all depends on the selling price of the mineral. If you are getting more profit, you can go deeper also. But if it is a low grade mineral, uh, because the selling price will not be sufficient to meet the cost of production, because the cost of production will be dictated by the amount of overburden you are going to removed. So that is one aspect, very good, that the grade of the ore, if high grade minerals are there, then you'll get more money. You'll get more money by selling in the market, and it will be profitable. But if it is a low grade mineral, then your selling price will be less, and you have to handle more amount of overburden, which will be uneconomical. So there will be loss of mining. So that is why, that is one reason why the that is the one reason, that is why it is called economic pit limit. Economic pit limit. uh, uh, Beyond that, you will not get profit. If you go down further, your profit will not be there. So that is why it is called economic pit limit. So if grade of the mineral is more, then of course you can go further deeper, so that you get the required amount of money, or you get the profit from the mine. Okay, so here again you see various open pit and ore body configurations are there. So this ore body, the green one, the green top one, uh, green one is the horizontal flat deposit. It is flat deposit. So usually the coal deposits are found in flat uh, horizontal deposits. So flat lying coal seams or bed are lying on the flat terrain, so like your coal deposits. And this coal deposit green color is overlain by the overburden white color. This overburden material you have to remove to get the ore. So that is why the stripping ratio is ore to how much, means the definition of stripping ratio is equal to the uh, amount of overburden removed to get 1 ton of ore. Amount of overburden removed to get 1 ton of ore. To get 1 ton of ore, how much overburden you are removing, that is called your stripping ratio. Usually stripping ratio is expressed in cubic meter per ton of mineral. Okay, and second one is showing a massive deposit. This deposit, massive deposit, uh, uh, in a flat terrain, uh, which are iron ore or sulfide deposits. Iron ore or sulfide deposit. So above the ore there is overburden. So this overburden is to be removed to get the ore. So this is a massive deposit in flat terrain. For example, iron ore mines, sulfide deposits. And the third one is inclined, yellow color, inclined deposit. Inclined deposit, dipping seam or bed, flat terrain. Example is anthracite. This is the ore dipping at an angle. So left side, this is the overburden. White portion is the overburden, and this is the recoverable by shovel. Recoverable by shovel mining, and possible over recoverable by drag line. This area, this triangle can be taken by the drag line. Okay, so this is the example of an inclined deposit. Then the fourth one is a massive deposit. Again, it is a inclined deposit, massive high relief copper deposit. So here overburden is this area, and the mineral is exposed to the surface. So you get the minerals quickly from the surface, and a little amount of overburden is to be removed. Okay, then this is a uh, 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 thick bedded deposit. There is little overburden is there in a flat terrain. For example, iron ore mining or coal mining. So this is the overburden you have to remove, and you have to get the minerals. So it is a hilly deposit, hilly type of deposit. Okay. So these are the various open pit and ore body configurations you come across while doing the open pit mining. So the other important aspect of open pit mining is stability of the slopes. Slopes should remain stable. Slope stability. You have to carry out slope stability study in open pit mining, uh, because if the stability of the slope is hampered, you cannot go for mining. They will fail down. The bench will fail down. So you have to carry out, you have to design stable slopes. So slope stability encompasses the analysis of static and dynamic stability of slopes of earth and rock fill dams, slopes of other types of embankments, excavated slopes, and the natural slopes in soil and soft rock. Slope stability investigation and analysis, including modeling and design mitigation, is typically completed by the geologists and engineering geologists and geotechnical engineers. So, uh, if the forces available to resist the movement are greater than the forces driving the movement, the slope is considered as a stable slope. So if the driving force is less than the resisting force, then the slope is considered to be stable. So the factor of safety of a bench is uh, uh, equal to 1 if the resisting force is equal to the driving force. If the resisting force is more than 1, if the resisting force is more than the driving force, then your factor of safety will be more than 1. So usually for surface mining projects, you should not go for mining if the factor of safety is less than 1. It should be always more than 1. Then only your benches will remain stable. So if it is 1, means it is very critical. The bench may fail down. So that is why it should be more than 1. Factor of safety should be more than 1. Preferably it should be 1.5 or 2. Keeping the factor of safety, the factor of safety should be more than 1.5, and it should go up to 2 factor of safety. So a factor of safety is calculated by dividing the forces resisting the movement by the forces driving the movement. In earthquake-prone areas, the analysis is typically run for static conditions and pseudostatic conditions, where the seismic forces from an earthquake are assumed to add static loads to the analysis. So here in this diagram, this is the discontinuity plane. This inclined line, bottom inclined line, is the discontinuity plane, and this is the tension crack. This is the tension crack. Height of the tension crack is Z, capital Z, and this small b is the location of the tension crack. This is the tension crack from the crest of the bench. The distance to the tension crack is small b, and this is the slope phase. This is the slope phase, and the capital H is the height of the bench. Capital H is the capital H is the height of the bench, and psi p is the angle of discontinuity plane. Psi f is the angle of the slope phase. So here if you see this u is the upward force, w is the downward force and V is the horizontal force. Three forces are acting on the bench. One is the upward force, one is the horizontal force, one is the downward force. So this downward force is W. W is nothing but weight of the sliding material. W is the weight of the sliding material, and U is the water uplift force on discontinuity. Water uplift force on discontinuity. And V is the horizontal water force in tension crack. So if the tension crack is filled up with water, so V is the horizontal force in tension, horizontal water force in tension crack. So by taking into these parameters, P is the location of the tension crack, Z is the tension crack depth, H is the slope face height, psi f is the slope face angle, psi p is the discontinuity angle, A is area of discontinuity. A, capital A, is area of the discontinuity plane. W is the weight of sliding material. U is the water lift force on discontinuity. V is the horizontal water force in tension crack. So from this diagram, you can calculate factor of safety. Factor of safety is equal to C into A divided by W sin psi P plus cot psi P tan phi. Tan phi. So what is tan phi? Phi is the angle of internal friction for all the materials. There is a angle which is called the frictional angle of internal friction. Okay, C is the cohesive force. Capital C is the cohesive force. Every material is having cohesive force. A is the area of the tension crack, area of the discontinuity plane, and divided by W. W is the weight of the material, sin psi p plus cot psi p into tan phi. So this is the way you have to calculate the factor of safety. So the open pit stability of the open cast mines, stability of the open cast mines is dictated by the pit slope angle, pit wall stability, rock strength of the rock, pit depth, at what depth you are going to mine, pit diameter of the pit, water damage, and stripping ratio. So here on the right side, you can see this black triangle. Black triangle uh, is a heap of material, each sand, for example, sand. So this angle 30° is called the angle of repose of the material. Angle of repose of the material means any material you drop, it has got an angle which is called, it has got some angle at which they will take a shape like this. So it is called the angle of repose of the material. Coal is having different angle of repose. Iron ore is having different angle of repose. So here in the bottom in an open pit mine, these are called the pushbacks. These are called the pushbacks, 35° to 45° pushbacks. These are the ores. The pink color are the ores. So pit slopes are cut into benches to aid stability and contain any slope failures. Rock must be stronger than sand, so the angle of repose can be larger. 45° is usually the maximum slope, and pit slopes are benched accordingly. The revenue from ore must pay for the cost of excavating the waste materials from the pushbacks and for excavating the ore. The slope cannot exceed 45°. and remain stable. So at some point of time, it becomes impossible or uneconomic to continue mining. So that point is called the economic pit limit. So your question was up to what depth you can go for open pit mining. You will go up to the depth where your revenue from the ore, the selling price of the ore must pay for the cost of excavating the overburden material from the pushbacks and for excavating the ore. So your cost of mining should be less than the revenue, should be less than the selling price, then only you will get profit. So if you are not getting profit, then why you should go for mining? This is the one aspect. So your profit is dictated by the grade of the ore. If the grade is high grade, you can go deeper also if you are getting the profits. And the slope angles cannot exceed 45 degree. Slope angles cannot go beyond 45 degree because of the stability point of view and because of the uh, transportation point of view. Therefore, it should remain stable uh, with 45-degree angle of slope. So at some point of time, it becomes impossible or uneconomical to continue open pit mining. So that is called the limit of open pit mining, variable limit, or the economic pit limit. So these are the pit wall stability, stable slope, unstable slope. Underlying fracture or fault plains may be there, magma may be there, landslides may be there. So most ore bodies are related to faulting. Fault plains may be there in the earth crust. Fault generates stresses in the host rock, rupturing it and causing faults in the rock. Faults are typically long linear features, so that if a circular pit is used to mine an ore body, it is likely to intersect a fault at 2 points, which leads to instability in at least 2 parts of the pit slope. So here shows this figure number 4 shows a landslide that occurred recently following rainstorms. A berm was created at the base of the slide to protect the main hull road. Figure number 5 shows a major instability. The likely cause is an underlying fracture or fault. The mine wishes to do a major pushback on this pit wall in order to gain access to more ore. This could be a challenging task. This is the pit slope versus the rock strength. Pit slope versus the rock strength. So greater rock strength means you can support greater bench height. If the strength of the rock is more, it can support greater bench heights, resulting in a steeper pit, a lower stripping ratio, and a less waste rock handling. And a greater final pit depth. A greater final pit depth requires a larger diameter pit, assuming rock strength and pit slope remains unchanged, resulting in a higher stripping ratio and more waste rock to be handled. So this is the diagram through which you can explain if you go if the rock strength is more, it can support greater bench heights and which will result in steeper pit, lower stripping ratio, less waste rock to be handled. In the case of a greater final pit depth, it requires a large diameter pit, assuming rock strength and pit slope remains unchanged, which will result in a higher stripping ratio and more waste rock. So these are the types of movements slides, rock slides takes place. Translation movement, planes of weakness are there, movement along slip planes takes place. This is the material flowing down, and this is the rotational movement like the slumping, in the homogeneous movement in the homogeneous isotropic material. The slumping takes place because of the rainwater. Rotational movement takes place. And this is the rock fall, how the rock is falling down from the top of the bench to the bottom. So the open pit slope failure is a problem in open pit mining. So there may be because of the structural problems. So pre-mining geological structures, particularly fault plains, represent zones of potential weakness in the rock mass and are therefore zones of potential slope failure and should be taken into account when designing the mine. So this is all about today. I have discussed. Tomorrow in the next class we'll discuss about the open pit slope failure, how the slope fails. So for today this is good enough. Thank you. Have a good day. Thank you. Have a good day. We'll meet you in the next week. So have a nice weekend. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Sir, can you say